In this tutorial, we will visualize the graphic and text output for the calculations performed at Bisco. For this tutorial we shall analyze the geometry developed in the previous video titled Psi-value for spacer. You can download the corresponding files from the link mentioned in the description. Upon opening the Bisco file, click on the Calculate system. Then Bisco asks if you want to recalculate triangulation, choose Yes. Then Bisco runs the calculation and upon finishing, open the graphic output. Now we turn on Fill Temperatures from the top toolbar to visualize the temperature field in the cross-section. Click on Triangulation Mesh to see the mesh used to perform analysis. The mesh is visible when we sufficiently zoom in. The software calculates the temperature at each mesh node, and does a linear interpolation between these nodes. Suppose you wanted to label the temperature at some critical point of this cross-section. Right-click on the node you wish to label and choose Label Node Temperature. Similarly, you can choose to label the maximum and minimum temperature of a color. We can label the temperature factor, linked to the coldest surface temperature. You also notice that we can label the material by choosing the color name. If you choose to label thermal properties, along with the name you also get the material conductivity. We can also label dimensions along the X or Y axis. Drag and drop to move the location of the label text box. You can write on the label and choose to edit, delete, or hide the labels in case. At Delete, you can choose between if you want to just delete this label, or all labels. If you want to turn off the triangulation mesh grid, you can click on the icon again to deselect it. Here, you can also render isothermal lines. To explore the settings of these lines, click on the temperature range at the top toolbar. The maximum and minimum temperatures for analysis are taken from external and internal environments. If required, you can change this by unchecking Use Boundary Condition Temperatures and Input Temperatures. Here, the first increment is represented by a pink isothermal line at the graphic output, and the second increment is represented by the red line. You can set the single value isotherm. Say we wanted to highlight the line at 10 degrees. Click on OK and close the dialog box. You can choose to fill off to clearly see the isotherms. You cannot distinctly see the single value isocurve line. This is because it overlaps with other isocurve lines. You can change this by clicking on Line Styles. Here you see the color assigned to isothermal lines. For single value line, change the line width to 3 for example and color to green. Here you can also change the line styles for surface humidity to plot condensation risk. Upon clicking OK, you can now distinctly see the single value isotherm. You can also fill with a material preview where you see conductivities in ascending order at the index for each material. Fill with bitmap if you want to see the material colors along with all colors labeled. If you choose Fill BC, only boundary conditions will be filled. You can turn on heat flow lines and turn off isothermal lines to visualize heat flux. You can zoom out and view entire geometry if you click on Zoom Total, and to save the image click on the Save icon here. You can spend some time trying each option in this graphic output to see which combination suits best for your visualization. We can now close the graphic output. Go to Derived Thermal Properties and select Internal Surface Relative Humidity, if you want to check the risk for surface condensation. For example, set high indoor relative humidity such as 60% to distinctly visualize the area of condensation. Now we perform analysis once again by clicking on Calculate System, and opening graphic output upon completion. Click on the humidity icon on the top toolbar. You can see 80% relative humidity line in blue, and the 100% relative humidity line in red. You can customize this line weight and color by clicking on Line Styles. Under Internal Surface Humidity Lines, you can adjust the properties of the lines. We can close the graphic output. Now we click on Text Output and click on the Input Data tab. Here you see parameters used for analysis such as mesh used for analysis, colors used, and their material conductivities. Under the Calculation Results tab, we can see the total number of nodes analyzed, along with derived thermal parameters. Here you notice the psi value, U equivalent tan 2D heat transfer, depending on which of the output was chosen before under Edit menu, at derived thermal properties. Here you notice input data such as boundary temperatures and various widths required for calculations, which we discussed in previous videos. Here we also see the minimum and maximum temperatures for each material. You now can close the text output window. Bisco allows us to generate an auto report. From the Edit menu, choose Graphic Report Definition. Here toggle to Yes by double-clicking on the cell, if you want to add an image in the report. You choose how you wish to fill the image with. We have seen visually each of these options at the graphic output window at the beginning of the video. For whatever parameters you like to choose, toggle to Yes, and the rest to No. Now at Bisco, you can click on Make Report, and then you notice the report file is generated. Once Word file opens, at Add in menu choose Bisco Load. Here at your file location, you will find a file with extension .bre. Once you choose that, the Word file will be updated with the auto-generated report. This Word template file can be customized. You can find this template under the Documents, under the folder Physibel, under Bisco. You will find Bisco template as a Word file. Thank you for watching. Hope you enjoyed learning Bisco.